Hello and welcome. Today we'll study Binomial Theorem. So now we'll start with factorial. Now what is a factorial? Factorial is generally defined for a natural number n, and we generally write factorial as either n with this exclamation sign, factorial n, or maybe with this angled bracket. And factorial n is actually nothing but it is a product of all the first n natural numbers. So it is nothing but 1 into 2 into 3 and up to n minus 1 and n. So factorial n is a short way or a compact way of writing the product of first n natural numbers. Now say for example, suppose I have to write factorial 1. So this is simply 1. Factorial 2, it is 1 into 2, which is 2. Factorial 3, it is 1 into 2 into 3, which is 6. Factorial 4, 1, 2, 3 into 4, which is 24. Factorial 5, 1 into 2 into 3 into 4 into 5, which is 120, and this is how we write these factorials. Now factorial 0 by definition is taken as 1. So the question is find the sum of first n terms of the series 1 into factorial 1, 2 into factorial 2, 3 into factorial 3. Now we know that we encounter such questions in sequence and series. There we use telescopic summation or method of difference to solve it. So what I know is I can write the general term for this series, and general term for this series TR I can write it as, so the first term is 1 into factorial 1, 2 into factorial 2, third term is 3 into factorial 3, then rth term is expressed as r into factorial r. Now what I can do is I can also write it as r plus 1 minus 1. So I have simply added 1 and subtracted 1 and then into factorial r. So I'll write r plus 1 into factorial r minus factorial r. Now what I know is r plus 1 into factorial r, it's a product of first r plus 1 natural numbers. So I can write it as factorial r plus 1 minus factorial r. So what is my first term? So first term will be, so if I'll put the value of r as 1, I can write factorial 2 minus factorial 1. Second term, factorial 3 minus factorial 2. Third term, factorial 4 minus factorial 3. And then finally its nth term, which is factorial n plus 1 minus factorial n. So now what is the sum of all first n terms? So I'll add them up. So when I'll add them up, so these terms, these successive terms, they'll get cancelled. So if I'll add them, the sum of first n terms of the series is simply factorial n plus 1 minus factorial 1, which is simply factorial n plus 1 minus 1. So the sum of first n terms of the series is given as factorial n plus 1 minus 1. So now the question is, if summation r varies from 0 to n, r square plus r plus 1 into factorial r is equal to 4000 into 4000 factorial, find the value of n. So again what I'll do is, I'll write the general term and I'll say maybe this is t r plus 1th term and this is r square plus r plus 1 into factorial r. Now what I can do is I can also write it as r square. Now I add one more r to it, so 2r plus 1 minus r into factorial r. So this is a plus b whole square, so I can write it as r plus 1 whole square minus r into factorial r. So I'll write it as r plus 1 whole square into factorial r minus r into factorial r. Now here r plus 1 whole square into factorial r, I can write it as r plus 1 into r plus 1 into factorial r, and this is r into factorial r. Now r plus 1 into factorial r is simply factorial r plus 1. So this is r plus 1 into factorial r plus 1 minus r into factorial r. Now I need to put the value of r starting from 0 and up to n. So if I'll put r as 0, I'll get my first term, and the first term will be, so 1 into factorial 1 minus 0 into factorial 0, which is 1. So second term will be, so if I'll for second term I'll put r as 1, so it'll be 2 into factorial 2 minus 1 into factorial 1. Third term, so it'll be 3 into factorial 3 minus 2 into factorial 2, and go on, and finally I'll put the value of r as n. So this is t n plus 1, so it'll be factorial n plus 1 into n plus 1 and minus n into factorial n. Now if I add all these terms, I'll get the value of this summation. So if I'll add them, so these terms, they'll get cancelled. So what I'm left with is the sum of all these n plus 1 terms will simply be n plus 1 into n plus 1 factorial, and it is given as 4000 into 4000 factorial. So if I'll compare, I can simply write the value of n should be 3999. So answering this question simply is the value of n should be 3999. So let us take up another problem. The problem is, let sk, which is defined as 0 when k is 1 and 1 upon factorial k minus 1 when k is greater than or equal to 2 for every natural number k, then we have to find the value of 100 square upon factorial 100 plus summation. The value of k varies from 1 to 100 mod of k square minus 3k plus 1 into sk. So what I'll do is, I'll first put the value of sk. So if I'll put the value of k as 1, so I'll get this value as 0. So I'll actually write it as 100 square upon factorial 100 and then plus summation. The value of k varies from 2 to 100 and then I'll write it as mod of k square minus 3k plus 1 and then I'll put the value of sk, and the value of sk is 1 upon factorial k minus 1. So as we all know, these factorial, they are positive numbers, so they'll come outside mod. So I'll get mod of k square minus 3k plus 1. So if I look at k square minus 3k plus 1, so if I'll find roots of this expression, I'll write it as 3 plus minus under root 9 minus 4 divided by 2. So this is 3 plus minus under root 5 by 2. So if I put it on a number line, so this is 3 minus under root 5 by 2 and this is 3 plus under root 5 by 2. Now 3 minus under root 5 by 2, this value root 5 is 2.2 something. So 3 minus 2.2 something is 0.8. So there'll be nearly 0.4 something, and 3 plus under root 5, so there'll be 5.2 divided by 2. So there'll be 2 point something. So nearly 2 point something. So what I know is the sign of the rightmost will be plus and then minus and then will be plus. So in this case, when the value of k is less than 2 point something, so this expression is negative, and when the value of k is greater than 2, then or 2 point something, then this value is positive. So I'll actually express it as 100 square upon factorial 100. Now for the first one, when the value of k is 2, if I'll put the value of k as 2, so I'll get it as 4 minus 6 plus 1 into 1 upon factorial 1 and then plus I'll express it as summation. The value of k varies from 3 to 100 and in that case, now this expression will be positive. So I'll simply write k square minus 3k plus 1 upon factorial k minus 1. So this is 100 square upon factorial 100 plus, now 5 minus 6 is 1, 1 upon factorial 1 is simply 1 and then plus, I'll write it as summation k equals 3 to 100. Now what I'll do is I express it as k square minus 2k plus 1 minus k upon k minus 1 factorial. So I'll write it as 100 square upon factorial 100 plus 1 and summation. The value of k varies from 3 to 100. So this is k minus 1 whole square upon factorial k minus 1 and then minus k upon factorial k minus 1. So I'll write it as 100 square upon factorial 100 plus 1 and plus summation. The value of k varies from 3 to 100 and this is, I can write k minus 1 as, so this k minus 1 will get cancelled and this will be factorial k minus 2 and then minus k into factorial k minus 1. So what I'll do is I'll start putting in the value of k. So if I'll put in the value of k, I'll get it as, so this is 100 square upon factorial 100 plus 1. So now if I'll put the value of k as 3, I'll get it as 2 upon factorial 1 minus, now here will be 3 upon factorial 2 plus, now if I'll put value of k as 4, so I'll get this as 3 upon factorial 2 minus, now it will be 4 upon factorial 3. And this series will continue and will continue up to 100. So here I'll get 99 upon factorial 98 minus 100 upon factorial 99. Now if I'll add them, so these terms they'll get cancelled. So what I'm left with is 100 square upon factorial 100 plus 1, and this is 2 upon factorial 1 and minus, so there'll be 100 upon factorial 99. So what I'll do is I'll multiply it by 100 and divide by 100. So I can write it as 100 square upon factorial 100 plus 3 and minus 100 square upon factorial 100, which will get cancelled. So answer to this question simply will be 3. So now that we have studied factorials and we want to study binomial theorem, so you have to study something called as binomial coefficients. So as discussed earlier, it was Indian mathematicians who have expressed binomial coefficients in terms of factorial. So binomial coefficient is generally defined as n and then this c and r, where n and r they are integers and n should be greater than or equal to r and it should be greater than or equal to 0. Then NCR, it is defined as factorial n upon factorial r factorial n minus r. So this is how we'll write a binomial coefficient, which is defined as NCR factorial n upon factorial r factorial n minus r, where n and r they are integers and n should always be greater than or equal to r and it should always be greater than or equal to 0. So say for example, suppose I have to write 9c2. Now 9c2 is simply the value of n is 9 and the value of r is 2. So I'll simply write it as factorial 9 upon factorial 2, and this is 9 minus 2, which is 7. So which is factorial 7. So I can write it as 9 into 8 into factorial 7 divided by, now factorial 2 is 1 into 2 and then factorial 7 will get cancelled. So answer to this expression will be simply 36. So let us take up an example, and the question is we have to prove 2ncn is equal to 1 into 3 into 5 up to 2n minus 1. So that is the product of first odd numbers into 2 to the power n upon factorial n. Now what we know is from the definition of binomial coefficient, we can write 2ncn as factorial 2n upon factorial n, and 2n minus n again will be factorial n. Now I know that factorial 2n is product of first 2n natural numbers. So I'll write it as 1 into 2 into 3 into 4 into 5, and there will be 2n minus 1 into 2n, and here in the denominator I'll write factorial n upon factorial n. Now what I'll do is I'll separate odd terms and even terms. So if I'll separate odd terms, I'll write it as 1 into 3 into 5 up to 2n minus 1, and here I'll write 2 into 4 into 6 and up to 2n divided by factorial n into factorial n. Now in each of these even numbers I can take 2 common. So I can take 2 common from this, I can take 2 common from this. So from each of the term I can take 2 common. So there are n terms, so I'll get this 2 to the power n. So I'll write it as 1 into 3 into 5 up to 2n minus 1, and there will be 2 into 2 into 2 into 2 n times. So there will be 2 to the power n, and here I'll get 1 into 2 into 3 up to n upon factorial n and factorial n. So I can write it as 1 into 3 into 5 2n minus 1, that is product of all the odd numbers, and then 2 to the power n. Now 1 into 3 up to n is nothing but factorial n, and this is factorial n into factorial n. So factorial n will get cancelled. So I'll write it as 135 2n minus 1 into 2 to the power n divided by factorial n. So let us take up another question. The question is if n minus 1 cr is equal to k square minus 3 ncr plus 1, then k belongs to which of the following given intervals? Now what I am given is n minus 1 cr, and this is k square minus 3 and this is nCn-r plus 1. Now I know that each of this n minus 1, it should be greater than equal to r, and it should be greater than equal to 0, and also n should be greater than equal to r plus 1, and it should be greater than or equal to 0. Now I'll use the definition of NCR. So I can write it as factorial n minus 1 upon factorial r, and this is n minus 1 minus r, and this is k square minus 3, and this is factorial n, factorial r plus 1, and this is n minus r minus 1. So now here n minus r minus 1 will get cancelled. Now I can write this as n minus 1 factorial upon factorial r, and this is k square minus 3. Now factorial n, I can write it as n into factorial n minus 1, and factorial r plus 1, I can write it as r plus 1 into factorial r. So I can cancel factorial n minus 1, and I can also cancel factorial r. So I can write k square minus 3 as r plus 1 upon n. Now from here I can say the value of r plus 1 upon n will always be greater than 0, but less than equal to 1. Now from here I can also say that the minimum value of r is 0, not minus 1. So if I put r as 0, I'll get this as 1 by n. So I can write it as, so the value of r plus 1 by n will be strictly greater than 0, but less than or equal to 1. So if I put this condition here, then I can write k square minus 3 is greater than 0, but less than or equal to 1. So if I'll solve the first part, I'll write k square minus 3 is greater than 0, and k square minus 3 is less than equal to 1. So k square is greater than 3, and k square is less than equal to 4. So if I take square root, I can write mod of k is greater than under root 3, and from here I can say mod of k is less than or equal to 2. So from here I can write either the value of k is less than minus root 3, or the value of k is greater than under root 3, and here I can say the value of k should lie between minus 2 and plus 2. So if I take the intersection of the two conditions, I can write, so the value of k should be less than minus root 3, or it should be greater than plus root 3, both not included, or the value of k should lie between minus 2 and plus 2, where minus 2 and plus 2, they are both included. So if I take the intersection, I'll get this value. So either the value of k should lie between minus 2 and minus root 3, or it should lie between minus root 3 and 2, where minus root 3 and plus root 3, they are not included, and minus 2 and plus 2, they are included. So the only option given in this question is from under root 3 to 2, root 3 not included and 2 included. So this is how we solve this question. Prove that 2ncn is divisible by n plus 1, or 2ncn upon n plus 1 is an integer. Now in order to solve this question, let us consider an expression which is 2ncn minus 2ncn minus 1. Now if I'll expand, I'll write factorial 2n factorial n minus factorial 2n factorial n minus 1, and then factorial n plus 1. So I'll write it as factorial 2n. I'll write this n as n into factorial n minus 1 into factorial n, and this again is factorial 2n factorial n minus 1, and for this n plus 1, I can write n plus 1 into factorial n. Now here I can take factorial 2n factorial n minus 1 and factorial n common. So if I'll take it common, I can write it as factorial 2n factorial n minus 1 factorial n, and here it will be 1 upon n minus 1 upon n plus 1. So if I'll take LCM and solve it, I'll get n minus 1 into n, and here will be n plus 1, and here will be n plus 1 minus n, so it will cancel. So it will be factorial 2n I'll multiply this n with n minus 1 factorial. So I'll write factorial n, and what I'm left with is n plus 1. Now 2n factorial upon n factorial, it is nothing but 2ncn upon n plus 1. So from here the result is twice ncn minus 2n cn minus 1, and this is 2ncn upon n plus 1. Now here on the left hand side I have two binomial coefficients, and binomial coefficients are nothing but integers, right? So this left hand side, it is an integer. So from here I can say 2ncn upon n plus 1, it should also be an integer. And if 2ncn upon n plus 1 is an integer, so that means n plus 1 divides 2ncn. So this is one of the method of solving this question. Before studying binomial theorem, we need to study three important properties of binomial coefficients. So the first property is NCR is equal to NCn minus r. Now, if I take left hand side, NCR, I can express it as factorial n upon factorial r and then factorial n minus r. And if I take my right hand side, NCn minus r. Now in this case, the value of r is n minus r. So if I'll write n. Now r here is n minus r, and then n minus r. So it'll be factorial n minus r, and n, it will cancel. So here I'll write factorial r, which is same as your left hand side. So at times in the question, you may get the answer 30C20, but then I know NCR is same as NCR minus r. So 30 minus 20 is 10. So I can write it as 30C10. So option may not be 30C20 there. Option may be 30C10. Now, one important way in which we use this same property is, suppose if I am given NCA equals NCB. So if the two binomial coefficients are equal, then we have two separate cases. Case 1, either the value of A is equal to B, or we know that NCR is same as NCn minus r. So if I'll add them, I'll get this value as n. So the other case will be the value of A plus B, it should be n. Now say for example, suppose it is given that NC3 is equal to NC5. Now here A cannot be equal to B. So the only solution possible in this case is the value of n should be equals to A plus B. So the value of n is 8. So this is how we'll use this first property of binomial coefficient. So that is NCR is same as NCn minus r. And we'll use this property in binomial theorem to illustrate that the binomial coefficients are symmetric. So the term equidistant from beginning and end, they'll have same binomial coefficient. Now the second property of binomial coefficients is NCR plus NCR minus 1 equals n plus 1 CR. So basically when I see this expression which has same n and the value of r differs by 1, then in that case it'll be n plus 1 and whichever the higher value, which is n plus 1 CR. Say for example, suppose I have 13C3 plus 13C2, then n is same, r differs by 1. So it is n plus 1, so it is 14C, and our higher value is 3. So it is 14C3. Now, how do we get this proof? So I'll take the left hand side. NCR plus NCR minus 1. So that is factorial n, factorial r, factorial n minus r, and then plus factorial n, factorial r minus 1, and then n minus r plus 1. Now I'll write it as factorial n, and for this factorial r, I'll write it as r into factorial r minus 1. So this is r, and then factorial r minus 1, and then factorial n minus r, and plus factorial n, factorial r minus 1, and here also I'll write it as n minus r plus 1 into factorial n minus r. So now I'll take factorial n, factorial r minus 1, and factorial n minus r common. So if I take it common, I can write it as factorial n, factorial r minus 1, factorial n minus r, and now I'm left with 1 upon r plus 1 upon n minus r plus 1, so which is factorial n, factorial r minus 1, factorial n minus r, and this is n minus r plus 1 plus r, and it is r into n minus r plus 1. So here r and r, it will cancel. So I'm going to write it as n plus 1 into factorial n, and I'll take this r with r minus 1. So r into factorial r minus 1, and I'll write n minus r plus 1, and then factorial n minus r. So here it will be factorial n plus 1, r into factorial r minus 1 will be factorial r, and here will be n minus r plus 1, which is nothing but n plus 1 CR, and that's your right hand side. So that's my second property of binomial coefficient. So if we have n same and r differs by 1, we can write it as n plus 1 CR. Now the third property of binomial coefficients is NCR upon NCR minus 1. It is n minus r plus 1 upon r. So here again n is same and r differs by 1, and the expression on the numerator, it is r, and here it is r minus 1. So I'll simply write n minus r plus 1 upon r. So say for example, suppose I have this expression which is nc5 upon nc4. So n is same, r differs by 1. So I'll simply write it as n minus 5 plus 1 upon 5. So it will be simply n minus 4 upon 5. Most of the time we'll use this property for simplifying the calculation. So if I have to prove, then if I'll take left hand side, so it is NCR upon NCR minus 1. So there is factorial n, factorial r, factorial n minus r, factorial n, factorial r minus 1, n minus r plus 1, n and n, it will cancel. So I'll write r minus 1 factorial, and I can write it as n minus r plus 1 into factorial n minus r, and here for this r, I write r into factorial r minus 1, and it will be factorial n minus r, so it will cancel, it will also cancel, so I'll get it as n minus r plus 1 upon r. Suppose the question is, we have to simplify NCR minus 1 plus 2 times NCR plus NCR plus 1. Now what I see is, n is same, r differs by 1, and again n is same, and again r differs by 1, and we have 2 into NCR. So what I'll do is, I'll write it as NCR minus 1 plus NCR, NCR plus NCR plus 1. So I'll use the property n same, r differs by 1, and here also it will be the same. So here I can write it as n plus 1, and the higher value is r. So this is n plus 1 CR. Now what about this one? So again it will be n plus 1, and then higher value is r plus 1. Now if I look at it again, so this is n same, and then r again differs by 1. So it will be nothing but n plus 2 C r plus 1. So answer to this question is n plus 2 C r plus 1. So let us take up another question, which is I need to simplify the expression which is 47C4 plus summation j varies from 1 to 5, 52 minus jC3. So I'll write it as 47C4. Now I'll expand the summation. So if I'll put j as 1, so 51C3, 50C3, 49C3, 48C3, and then 47C3. So now what I'll do is, I'll reverse this series. So if I'll reverse it, I'll write it as 47C4, 47C3, 48C3, 49C3, 50C3, and plus 51C3. Now if I look at these first two terms, now here n is same and r differs by 1, right? So using the property, so it is n plus 1, so it is 48C4. Now if I'll take these two together, so here again n is same, r differs by 1, so I'll get 49C4. Taking these two together, adding them, 50C4, adding these two, 51C4, and finally if I'll add them, I'll get my answer, and there'll be 52C4. So answer to this series will simply be 52C4. Now let us take up an example. Say for example, the question is NCR minus 1 equals 36, NCR equals 84 and NCR plus 1 equals 126, and I need to find the value of N and R. Now what I see is N is same, R differs by 1, N is same and R differs by 1. So what I'll do is, I'll take these first two expressions and I'll express it as NCR upon NCR minus 1, and I can write it as 84 upon 36. Now N same, R differs by 1, so it is N minus R plus 1 upon R, and here it will be 7 by 3. So it will be 3N minus 3R plus 3, and that's equals to 7R. So I'll simply write 3N minus 10R is equal to minus 3. So I'll get a linear equation in N and R. Now I'll take the second and third expressions. If I take the second and third expression, I can write it as NCR plus 1 upon NCR. So here again N is same and R differs by 1. So it will be N minus R. Now R in this case is R plus 1. N minus R plus 1 upon R, which is R plus 1. And this value is equal to 126 by 84. So I'll cancel 1 with 1. So I'll write N minus R upon R plus 1. And here I'll get it as 3 by 2. So if I'll multiply, I'll get 2N minus 2R equals 3R plus 3. So I'll write 2N minus 5R is simply equal to 3. So that's my second linear equation. So if I'll solve the two equations, so I can write, so if I'll multiply it by 2, I'll write 4N minus 10R is equal to 6. So I'll subtract the first one. So I'll get the value of N as 9. And if I'll put the value of N as 9, 18, 18 minus 3, 15, I'll get the value of R as 3. So for this question, the value of N is 9 and the value of R is 3. So we'll take another question, which is, if MCR minus 1, MCR and MCR plus 1, they are in arithmetic progression, then I need to find the value of M square minus M 4R plus 1 plus 4R square. So we know the condition for arithmetic progression. So if A, B, C are in AP, then twice B equals A plus C. So I'll simply write it as 2 times MCR, and it is MCR minus 1 and MCR plus 1. Now here M is same, R differs by 1. M is same, R differs by 1. So what I'll do is, I'll divide everything with MCR. So if I'll divide it with MCR, I can write it as MCR minus 1 upon MCR and MCR plus 1 upon MCR. Now this is 2. Now here M is same, R differs by 1, and this R is greater than R minus 1. So I'll simply write it as M minus R plus 1 upon R, and here also I can write it as M minus R plus 1 upon R plus 1. So here 1 and 1 it will cancel. So if I take LCM, I can write it as R into R plus 1 and plus M minus R into M minus R plus 1 upon M minus R plus 1 into R plus 1. Now I need to express it as a quadratic equation in M. So I'll write it as 2 times M into R plus 1 and then minus 2 times R square minus 1. Here will be R square plus R, and then I'll have this as M square plus minus R plus 1 into M minus R into M, and then plus R square minus R. Now I'll take everything on the right hand side. So I can write M square. Now with M I have this expression and I also have this expression. So it'll be minus 2R and then minus 2R. So there'll be minus 4R and then plus 1. So minus 4R plus 1 into M, and then what I'm left with is, so this is 2R square and then again it will be 2R square, so there will be plus 4R square. So now what I'm left with is this 2. So the answer to this expression will be simply 2. Now let us take another question, which is I need to simplify this series, which is given as the summation k varies from 1 to n, and it is k square nck upon nck minus 1. Now here again what I see is its general term, or I should say its kth term, is given as k square into nck upon nck minus 1. Now here again n is same and k differs by 1. So again I'll use the same formula, so which is k square and it is n minus k plus 1 upon k. So here k and k will cancel. So I'll write its kth term as, so if I'll multiply it here, I can write n plus 1 into k and then simply minus k square. Now I need to find the sum of first n terms. So sum of first n terms is simply summation. The value of k varies from 1 to n, and that is simply tk. So if I take a summation, so I'll write summation k varies from 1 to n, it will be n plus 1 into k and then minus k square. So now it's a summation in k, so n plus 1 I can take it out, so I can write n plus 1 into summation k and then it will be summation k square. Now summation k, when k varies from 1 to n, it is n into n plus 1 by 2, and summation k square, so it will be n plus 1 to n plus 1 whole divided by 6. So let us take another question. Now in this, I need to simplify this expression, which is 1 plus c1 upon c0. For brevity, we are going to write nCr as simply cr. So c1 upon c0, 1 plus c2 upon c1, c3 upon c2, and 1 plus cn upon cn minus 1. Now in this case, I have product. So what I'll do is, I'll write its general form and I'll use pi. So this pi, it is 1 plus, now it is suppose c1, then it is c0, c2, then c1, c3, then c2. So it will be simply cr upon cr minus 1. So I'll simply write ncr upon ncr minus 1, where the value of r varies from 1 to n. So I'll write it as product of these n expressions. Now here again I see n same. So here again I can see n is same and r differs by 1. So I can write it as, so this is product, value of r varies from 1 to n, and this is 1 plus, and it will be n minus r plus 1 upon r. So if I take LCM, so I can write, so this is r and here will be n minus r plus 1 plus r. So r and r it will cancel. So I can write this product of n plus 1 upon r. Now if I'll put the value of r as 1, I'll get n plus 1 upon 1. If I'll put value of r as 2, I'll get n plus 1 upon 2, n plus 1 upon 3, and then finally I'll get it as n plus 1 upon n. So it is n plus 1, n plus 1, n plus 1, n times. So it will be n plus 1 to the power n, and here in the denominator I'll have 1 into 2 into 3 up to n, so which is simply nothing but factorial n. So answer to this series is, or the simplification of this result is, n plus 1 to the power n upon factorial n. So this is how we solve these questions.